Hi, I'm Chen Jiankai. In this video, my group will be discussing about our statistics assignment regarding the relationships between biochemical oxygen demand, BOD, dissolved organic carbon, DOC, and synchronous fluorescence spectra, SSCM readings using Microsoft Excel as our choice of statistical software. We discuss our assignment at Cisco Web Apps meetings. Without further ado, let's begin our video.
Hi, my name is Nur Adiba binti Rozaini. So this is our 50 data for BOD, DOC, and SFS for 4 locations of water resources that is generated by random number by using scientific calculator. For the first question, which is describe and summarize the data numerically and present the data graphically where appropriate. For these 4 slides shows the table and graph for biochemical oxygen demand BOD versus dissolved organic carbon DOC for sample of water resources at location 1, 2, 3, and 4. We can't make any conclusion because there is no relationship between BOD and DOC, but we can make conclusion between the location and average of BOD. So we go to the next slide. This is the table and graph for all locations versus average of BOD and also pie chart of all locations and the number of BOD. From this graph and pie chart, we can conclude that the sample of water resources at location 1 has the highest BOD while the sample of water resources at location 2 has the least of BOD. From this graph and pie chart, we can conclude that the sample of water resources at location 1 has the highest BOD while the sample of water resources at location 2 has the least of BOD. It is maybe the water resources at location 1 were polluted or it is located near to the factories that dumping the toxic waste into the rivers or any other water resources near it. While for the water resources at location 2 are clean and free from pollutions, maybe because it is located far from the factories or it is located at the village area.
Hi, I'm Winnie. Now I want to discuss about the question 2. First of all, we need to categorize a table with the DOC readings and the locations of water sources. Now we can start to test the relationship between the DOC readings and the locations. For first step, we need to do a hypothesis. For step 2, which is test statistic, we need to calculate all the computations for ANOVA and summarize all the calculations into a tabular method which called ANOVA table. From ANOVA table, we can do decision rule, such as reject H0 if F test is greater than F distribution with K-1 and N-K degree of freedom, or reject H0 if alpha is greater than p-value. For last step, which is do conclusion. From this question, we can conclude that there is no difference on DOC readings with locations of water sources. This is because alpha in this question is 0.05 and is less than p-value. So it is failed to reject H0. For ANOVA model, there is an equation which is Yij is equal to mu plus alpha I plus random error ij. And its assumption for ANOVA, which are the expected value of random error is equal to 0 and the variance of random error is constant for OX.
My name is Nufara Hazira and I'm going to explain about number 3.1. So, by applying a simple linear regression, fit a linear regression model that relates BOD and SFS. So, we are going to use Excel for this question. So, in Excel, first we have to pick the File tab and then go to the right side and choose Data Analysis. From there, a pop-up will show. From the Analysis tools, choose Regression and then click OK. Next, from the regression, we have to fill in the input Y range and input X range. In this case, our Y is the BOD and X is the SFS, since the BOD is the dependent variable and SFS is the independent variable. So to fill in the input Y range and input X range, click the first row of the data and then drag it until the last row. Same goes to the X range, and then click OK. So we will have the summary output. We have the regression statistics, ANOVA, and then the third table. Linear regression model is y hat equals to alpha hat plus beta hat x. So for this case, look at the third table and then look at the coefficients for intercept and x variable 1. The intercept is the alpha hat and then the x variable 1 is the beta hat. So our linear regression model is y hat equals to 1.6793 minus 0.0041x.
Hi, I'm back. Sorry for the lack of visual appearance. I will like to discuss about the linearity between BOD and SFX. So for first step, we have to set up the hypothesis, where H0 null hypothesis is the slope is equal to 0, means there is no relationship between BOD and SFS. Then the alternative hypothesis H1 will be B beta not equal to 0. That means that there is linear relationship between BOD and SFS. Next, we will set our significance level at 1% or alpha equals to 0.01. After that, I will use the Excel summary output to compare the significance F and alpha. That significance F value will be available at ANOVA table. Thus, for our decision rule, if the significance F value is bigger than the alpha value, we will accept the null hypothesis, means there's no relationship between BOD and SFS. Or else, we will reject null hypothesis, which means there is linear relationship between BOD and SFS. The significance F value will be available at the ANOVA table. That means the F value will be 0.7925, which is larger than the alpha value. Thus, we have to accept the null hypothesis. The conclusion: there is no linear relationship between BOD and SFS at 1% significance level. For the correlation value R, we can find it at the summary output 2, which is at the regression statistics R squared. R squared equals to 0.0016, which means that the R value will be 0.04, which is very close to 0. This also proves that there is no linear relationship between BOD and SFX.
Hi, I'm Ying Ying. I will discuss about question 4. First of all, we need to categorize the BOD reading. By using the goodness of fit test, we get our hypothesis H0, which is the BOD reading follow the normal distribution, while the alternative hypothesis does not follow the normal distribution. Since the observed frequency is given, we need to find the expected value by multiply the probability with n. The probability are not given, hence we need to calculate the probability of each categories. And then we calculate the expected value. The calculated expected value must be at least 5. So we need to combine the expected value with the next value. After combine, we can do the chi-square test. The next step is to do our decision rule, which is reject H0 if the chi-square test greater than the chi-square alpha k minus p minus 1. From the chi-square distribution, we can get our chi-square value, which is 11.0705. The chi-square test that we get is 21.41689. Since the chi-square tests are greater than the chi-square alpha, which is 11.0705, therefore we reject H0. So we can conclude the BOD reading does not follow the normal distribution with mean 1.5 and variance 0.135 at significant level alpha equal to 0.05.
That wraps up our discussion video. So we will see you at the next video.